Okay, hi and welcome to video notes 8.4, where we're going to explore some more multiplication properties of exponents, specifically this time the power rules. That's kind of a general term for what we're going to do, but we're going to look at specifically what happens when I have a base to an x with raised to some exponent, and it's also raised to another power. What do we do? Additionally, what happens if I have a combination of bases that are raised in parentheses, and I have whatever exponents on them, and then they're raised to an exponent. So the same base inside parentheses or different bases, we're going to look at what happens when we raise them to a power, hence the power rules. So if we have a single base underneath a set of parentheses, we're going to employ the power to a power rule. And what a power to a power rule says is that we take whatever base is on the inside, and then we multiply it, not add it, to the base that's being applied to it. Or I'm sorry, the power that's being applied to it. So there's a multiplication there. Where we saw before, if we had two like bases and we multiplied them, m and n, that we added them. Well, this is exactly what we see here. These should be added. That should be m plus n. Sorry, that's wrong. So if we have two like bases being multiplied, we added the exponents. Okay. In this case, we have a power to a power, not two like bases being multiplied. So different, don't confuse them. We find out that they're multiplied. So in this case, they're being added. Okay. If that same property, we take it and kind of employ the reverse of it, that would be similar to what we're seeing here. That each base inside, or what we call a power of a product, each base inside will be raised to that power that's on the outside of the parentheses, or that they're being raised to. So both bases, again under multiplication, will be raised to that power of n. Okay, so very similar to what happens here, but these powers are being multiplied in the power to the power. This one says that every base inside that's being raised to the power of a set of parentheses should receive that base. And again, don't forget our multiplying of like bases, what happens with negative exponents and zero exponents. Those will all come into play here. And again, now that we have a lot of rules with exponents, there's lots of different ways to solve these, and not everybody will take the same path. And that's fine, as long as you're employing these rules correctly. Okay, so let's see a couple quick examples of what this looks like. All right, so here's an example in example 1 that has a base that's raised to an exponent, but that is additionally raised to the power of 6. So what's going to happen? Well, quite simply, that 3 is going to be multiplied by the power of 6, or resulting in x to the 18th, because we multiply our exponents when it's power to a power. All right, let's see that again. This time we've got a to the negative 4th raised to the 7th power. Again, a single base raised to a power means that we're going to bring that base out. It's going to have a base of negative 4, but this time it's going to be multiplied by the 7th power. That's going to result in a to the negative 28th. And the negative then means that we have to move, when there's a negative exponent, we have to move that base. Whatever, if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. In this case, it's in the numerator because it's not below 1. And so it's going to become 1 over a to the positive 28th. And we're done with that one. All right, what happens if we've got a couple bases and then there's a power to a power and a multiplication? How do we deal with this? Well, don't forget, order of operations rules supreme here. So we have to address the parentheses first, or in this case, the exponent, because that would also go with the parentheses, right? Please excuse my dear Aunt Sally. So we have to address both the parentheses and exponents first. So in this case, we're going to break this apart into c to the 5th times, and then we're going to address this part. Our power to a power rule says that we're going to multiply these exponents. So I'm going to have c to the 3rd times negative 2. And we've addressed the parentheses now, so we can drop them. And this is going to leave us with c to the 5th times c to the negative 6th. And again, you're like, wait, do I move the 6? Not yet. Let's go ahead and employ our rule of multiplying like bases. So that's going to tell me I'm going to combine them under one base, and I'm going to take 5, and I'm going to add it to a negative 6. Well, that's going to result in c to the negative 1. Now, it's probably a good time to address that negative exponent and move its position. So what we're going to find then is that's going to be equal to 1 over c to the first power, or 1 over c. Let's see that again. Here's number 4. So in this one, same kind of idea. So we're going to go ahead and address the parentheses in this exponent first. So right here, t to the 7th raised to the negative 2 power. So that's going to be equal to t squared times t, and again, power to a power says multiply exponents, so 7 times negative 2. We're going to go ahead and address that part, t to the 7 to the negative 2. So t squared drops down, t times 7 minus 2 is t to the 5th. Employ like bases being multiplied, which means that it's going to be t squared plus 5. And then those are going to combine to make t plus 7. And we're done with that one. All right, let's see one more, and this time we're going to see two more. We're going to throw in the idea of a coefficient. So this one, even though this is a coefficient, they're multiplied. So let's look at this like 2 times z raised to the 4th. These both now count as bases. So even though it's a coefficient, it counts as a base. So if we employ our rule back up here, power of a product, again, they'll count as separate bases. So power of a product says that both of these bases get the 4. So what does that look like? It looks like 2 to the 4th times z to the 4th. And 2 to the 4th we can multiply out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we get 16z to the 4th. All right, let's do that one more time for these notes. Again, we've got a base of 4. They're under multiplication. We've got a base of g raised to the 5th power, and those are being raised to the power of negative 2. So we're going to look at it like 4 times g to the 5th, and both of these bases are going to get that negative 2. So let's go ahead and employ that now, power to a power, or I'm sorry, power of a product says 4 is now raised to the negative 2 power times g, and power to a power says that those are going to be multiplied together, or g to the 5th times a negative 2. So let's not deal with that negative yet. Let's save it for a minute. Oops, let's write the right number. 4 to the negative 2, we're going to leave it for just a second, times, let's clean this part up here, that's going to be g to the negative 10th then. And if you look, both of these bases, because they're both negative exponents now, both of them need to move its position. They're both currently in the numerator, so we're going to move both to the denominator. And that means that there's going to be a 1, because there's nothing left in the numerator to hold its place. And that's going to be over 4 squared times g to the 10th. They become positive once you move them. So if I clean this 4 squared up, it's going to be 1 over 16g to the 10th. All right. Thanks for watching these. I'm going to do a couple larger examples in the next video.